Hello, everybody, and welcome to today's learning lesson of lockout and tagout safety in the workplace. So our overview of this is going to be talking about the following: types of hazardous energy, energy control procedure, and additional lockout tagout requirements. The reason why we're learning all of these is because it's important. So when we talk about this, you're going to be learning about why lockout tagout programs are necessary, when a program must be developed, the procedures and steps the program must contain, the employer and employee roles and responsibilities, and program training and audit requirements. Lockout-tagout procedures prevent the unexpected startup or release of energy from machines and equipment during servicing or maintenance. Employees face severe injuries such as amputations, fracture, or even death if this hazardous energy is not controlled. Not only are these procedures essential for employee safety, they are required. Lockout-tagout is one of the most top 10 frequently cited standards during worksite inspections in the United States, resulting in large fines to cited businesses. There are around 3,000 citations for lockout-tagout violations a year, and the majority of those are in manufacturing facilities. Employers must establish a lockout-tagout program if employees are engaged in the cleaning, repairing, servicing, setting up, or adjusting of machinery, equipment, or other processes that could start up unexpectedly and release stored energy. The program must establish procedures for removing the energy supply from machines and equipment and for applying the appropriate lockout or tagout devices on the energy isolating devices to prevent unexpected startup or re-energization. When appropriate, the procedure must also address stored or potentially accumulated energy, and also it must include requirements for training and program review. It is important that programs such as this one are customized according to our equipment and our conditions that are specific to each individual site. The roles and responsibilities for various components of the lockout-tagout program include the following: affected employees whose job require them to operate or use machines or equipment that need servicing or maintenance. We have authorized employees who are locking out and tagging out machines or equipment in order to perform servicing or maintenance on that machine or on that equipment. And then we have other employees who work in an area in which a machine or equipment servicing or maintenance is being performed. The specific training requirements for each role will be addressed later on. An energy isolating device is a mechanical device that physically prevents the transmission or release of energy. Examples include manually operated circuit breakers, line or gate valves, blocks, or any similar devices. An energy isolating device is not the same as an on and off switch or just a push button. Hardware is the device that connects directly to the energy isolating device to physically prevent it from being moved from the off position. Examples include locks, chains, wedges, blocks, or pins. Zero energy state is the point at which all stored or residual energy has been released, restrained, or dissipated. This means that there is no energy present that can injure a worker. So when we talk about types of hazardous energy, this course is going to include a lot. So what you need to know is energy sources that require hazard assessment. And those types of energy that we'll talk about will be electrical, mechanical, chemical, hydraulic, pneumatic, and potential. Before developing the processes and procedures in the lockout-tagout program, we need to conduct a hazard analysis and assessment to identify all hazardous energy sources. These will vary based on machines, equipment, and processes if present. The types of hazardous energy identified may include electrical, mechanical, chemical, hydraulic, or pneumatic energy. Also considered stored or potential energy, thermal sources, and human factors such as misuse of equipment. Electrical energy is the most common type of energy and originates from generated electrical power, static electricity sources, and electrical storage devices such as batteries and capacitors. Exposure to excess electrical energy may result in electric shock, burns, electrocution, or explosions. Mechanical energy, also known as kinetic energy, refers to the energy created by the actual movement of parts of a mechanical system such as power transmission apparatus, flywheels, belts, or pulleys. In addition to the energy created by motion, contact with moving parts can crush, fracture, cut, or amputate a body part. Chemical energy is the energy produced by chemical reactions. It may cause chemical splashes or splatters, resulting in chemical burns or other injuries. This energy often needs to be controlled in pipes and other portions of the equipment. In addition to controlling chemical energy, please be aware of other chemical-related dangers in the workplace. Chemical reactions can produce gas or heat that interacts with other materials to cause hazardous or explosive situations. Please take precautions with inherently hazardous chemicals such as acids and bases, solvents, corrosive solutions, and combustible liquids. Pneumatic energy is the product of stored pressure from gas or air with pneumatic lines and vessels. The pressure stored in the line must be relieved prior to servicing or maintenance. Pneumatic pressure may be encountered in pressurized systems, compressors, house air, air power tools, and gases. Hydraulic energy is derived from the motion and pressure of liquids. It is commonly found in pistons and similar devices, such as hydraulic brakes, piston motors, and hydraulic presses. Potential energy is stored energy that can be hazardous if released. Some examples are the following: objects falling as a result of gravity, such as elevated machine parts, springs that are compressed and could release stored energy, and thermal energy, such as high or low temperatures resulting from mechanical work. Next, we're going to focus on energy control procedures. Please look over the following list, and this is what we are going to be focusing on as our outline. Before beginning service or maintenance, the following steps must be followed in sequence according to the energy control procedure. Prepare for shutdown, isolate energy sources, apply locks and tags, control residual energy, verify energy control methods. So first, again, is prepare for shutdown. The first step is to notify affected employees of these activities, and these authorized employees must consult the energy control procedures, identify the shutdown procedures for the equipment, the energy and potential energy sources of the equipment, the appropriate energy isolation devices needed, quantity and type of lockout, tagout devices required. The second step in the energy control procedure is to shut down or turn off the equipment by its normal start-stop method, deactivating its operation. Equipment toggle switches and on and off buttons are commonly used. The energy used to power the equipment or machinery was identified in the first step. The third step prevents this energy from reaching the equipment by disconnecting or isolating the equipment from the power source. That way, even if the machine or equipment is turned on, it can't start up because its power source is not available. The fourth step is the application of the locks and tags by authorized employees to the energy isolating devices. Locks will be attached in a manner that will ensure that the energy isolating device, and therefore the machine or equipment, cannot be operated until the lock is removed. The devices must be in the off position before they are locked out. The tag indicates that the energy device and the equipment being controlled may not be operated until the tag is removed. All locks and tags must be securely attached to the energy isolating device, and they must include the name of the employee who applied the devices. Lockout of machinery is the preferred method of preventing an accidental release of hazardous energy. However, if the energy isolating device does not allow the use of a lock, a tag may be used. The tag must be attached at the same location that the lock would have been attached. There are many disadvantages to using a tag-only system, and a tag is a warning that the machinery should not be energized, but does not provide any physical protection, and may provide a false sense of security. Regardless of the type of lockout or tagout device used, the following requirements still apply. The device must be durable enough to withstand standard work conditions. This includes tags being resistant to corrosive materials such as acid. All devices must have a standard color, shape, and appearance throughout the workplace. The devices must be substantial enough to prevent accidental removal. Tag attachments must have a minimum unlocking strength of 50 pounds. The device must be labeled with the name of the authorized employee who applied and can remove the lockout device. Tags must be readable and understandable by all employees, and they must have specific instructions to not operate or energize equipment. They must also be single-use, self-locking, and non-releasable. The tag attachment should be applied by hand. When a crew or other group performs service or maintenance on equipment, a single authorized employee must assume the overall responsibility for the control of hazardous energy for all members of the group while the servicing or maintenance work is in progress. Each person who enters the danger zone will be required to verify the hazardous energy sources have been locked out and the keys to these have been secured in a group lockbox. When they affix their personal devices to the group lockout box or equivalent, seen as in the image. So look at the image now to see what we're talking about when we're talking about these tags. For example, multiple valves and breakers require lockout by 3 people who will be working on the same piece of equipment. A lock and tag is placed on each lockout location and the keys are stored in the group box. Each employee then places their personal locks on the group lockout box. Group lockout procedure must provide all employees with the same level of protection provided by an individual lockout or tagout device. The fifth step is to control all residual, stored, or potential energy. This is accomplished by releasing, restraining, or dissipating stored electrical, pneumatic, or hydraulic energy. Additional measures may be necessary to prevent the reaccumulation of energy. One method is to isolate the space to prevent material inflow. Do this by binding and blinding the lines, disconnecting and misaligning the lines to prevent any material from entering the space, or double blocking all valves and bleeding any residual materials or liquids downstream from the valve. Verification is the final and most important step. The authorized employee must assure that the equipment will not start prior to servicing and maintenance. With the lockout devices securely in place and all the power turned off, assure that the switches, valves, and other mechanisms cannot be turned off. Activate equipment control switches and levers and depress start buttons to assure power is isolated and the equipment does not start up. Return switches, levers, and buttons to the off position, and use a meter to assure that the electrical energy is not present. Only the authorized team member who placed the lock or tag is authorized to move it and remove it once work is complete. Start up the procedures by including the following: inspecting the area and remove all tools, rags, and other materials. Assure that the equipment is operationally intact. Notify affected employees that the equipment will be restarting. Check the work area to assure all employees are safely positioned, and verify all controls are in the neutral or off position. This third section will be talking about the additional requirements. So we will go ahead and dive in next, talking about multiple shifts. What happens when multiple shifts occur, but there's only one device? So lockout, tagout that occurs over multiple shifts must protect employees in both the outgoing shift and the incoming shift. Assure that protection for employees extends between shifts and that energy isolation devices remain locked out from the previous shift. AKA, we're not taking this off. The upcoming shift must verify the energy is isolated and correctly locked out. All employees involved with the lockout tagout must be trained before any service or maintenance activities begin, and the employer must certify that the training has been given. Training is usually divided to 2 categories: for affected employees and for authorized employees. Affected employees who operate the machinery must know the following: the purpose and the use of energy control procedures, the limitations of tagout only program if used, how to recognize when a procedure is being used, who is authorized to perform work on the machinery or equipment, and that is attempting to restart or re-energize the equipment. Authorized employees who perform the lockout, tagout procedures have additional responsibilities and therefore need more detailed training. Retraining is required when there is a change in the employee's job assignment, change in machines, equipment, or processes that present a new hazard, the energy control procedure is modified, or a periodic inspection reveals or the employer has reason to believe that there are inadequacies in the employee's knowledge. An audit of the lockout tagout program must be performed at least annually. A review of the program is also performed if a weakness or issue is noted. Audits must be documented and the records maintained, and the audit must include the following information: the equipment being controlled, the date of review, the names of equipment involved, and names of employee involved, and the name of the auditor. If an outside contractor services or maintains your machinery, the on-site employer and contractor must inform each other of the respective lockout tagout programs. Assure that their procedures are at least as effective as your organization's procedures and are in compliance with all codes. Communicate the lockout processes of the contractor with all affected employees. In summary, the lockout tagout procedures can prevent unexpected machine startup during servicing or maintenance. Keep in mind the types of hazardous energy, which include electrical, mechanical, chemical, pneumatic, hydraulic, and potential. And a lockout tagout program, which includes training and auditing, is required for equipment that could be potentially energized. Lockout systems are more protective than tagout only systems. All right, thank you everybody for today and listening and paying attention and everything. So if you have any questions, talk to me, which is Claire, your HR partner. Talk to John Kelly, our chief engineer. Talk to your manager. We are here to help. If you ever have any more questions about this or any other subject matter, we are here for you, and we will have more trainings to come. So thank you and have a wonderful day.